So, good morning to all. I am Kumar P, Assistant Professor in Chemistry from Knowledge Institute of Technology. So, we are going to discuss spectroscopy. So, first of all, before that, I have to say the introduction about spectroscopy. The spectroscopy is one of the most powerful tool available for the study of atomic and molecular structure. The spectroscopy deals with the study of interaction of electromagnetic radiation with matter. So when we are passing electromagnetic radiation in the chemical sample, the atoms or molecules may absorb the electromagnetic radiation. So during the interaction, the energy is absorbed or emitted by the matter. So when it is absorbed, that is called absorption spectroscopy. When it is emitted, which is called emission spectroscopy. The measurement of this radiation frequency are made using spectroscopy. So next we have to discuss the study of spectroscopy can be carried out under the following headings: atomic spectroscopy and molecular spectroscopy. So first of all, we have to see the atomic spectroscopy. It deals with the interaction of electromagnetic radiation with atoms. When we are passing IR radiation or UV radiation or microwave radiation in the sample, the atoms will only be absorbing the electromagnetic radiations. So which is atomic spectroscopy. When it absorbs the electromagnetic radiation, it gets excited from ground state electronic energy level to excited state electronic energy level. Next, we have to see molecular spectroscopy. It deals with the interaction of electromagnetic radiation with molecules. When we are passing UV radiation or IR radiation or microwave radiation in the chemical sample, the molecules will be absorbing the electromagnetic radiations. When it absorbs the electromagnetic radiation, this results in transition between rotational transition, vibrational transition and electronic transition. So we have to see one by one about rotational, vibrational and electronic energy levels. Spectrum. So before that, we have to see the meaning of spectrum. How does a spectrum arise? So it is classified into absorption spectrum and emission spectrum. So absorption spectrum, if we are passing electromagnetic radiation in the sample absorbs the energy, which is called absorption spectrum. So after the absorbing sample, if emits the which is called emission spectrum. So now we have to see what is electromagnetic radiation. So electromagnetic radiation is a form of energy that is transmitted through space at an enormous velocity. As the name implies, an electromagnetic radiation has an electric component and a magnetic component. So the electric field varies in the direction of y-axis and magnetic field varies in the direction of z-axis. So this is the a diagram of electromagnetic radiation. Here we can say the wavelength and a magnetic component. Wavelength means the two adjacent crust or tuff is known as the wavelength. So molecular or absorption spectra is classified into three types of transition. So first one, rotational transition, vibrational transition and electronic transitions. So how the transitions are occur in the chemical sample. These transitions are accompanied by the absorbance of electromagnetic radiation. So before that, we have to see this energy level diagram. The energy level diagram showing different transition in the molecules. Thus, a molecule of a compound have large number of energy levels. Small amount of energy is required for transition between some of these, while large amount of energy is required for other levels. The various types of spectra, the regions in which the spectra lie and the energy changes that takes place in the molecules due to absorption of radiations are listed below. So here this is the energy level diagrams of ground state and excited states. Here we can explain about electronic vibrational state and ground electronic state and rotational energy levels. So first of all, here we have to see the rotational spectra or rotational transition. So rotational energy arises when the molecules rotate about an axis perpendicular to the internuclear axis. So this rotational transition occurs in the microwave regions. The microwave region range is between 1 to 100 centimeter inverse. So if the range between 1 to 100 centimeter inverse, which is called microwave region, or it is region. So this is a rotational energy in and fro rotation of the molecules and atoms. Examples: rotational spectra are shown by the molecules like hydrochloric acid, carbon monoxide, water, nitrogen oxide, etc., which possess a perm dipole moment. Homonuclear diatomic molecules such as hydrogen molecule, pin molecule, and linear polyatomic molecules like carbon dioxide do not show microwave spectra because they do not possess a dipole moment. So here in this case we have to analyze, our judgment is the molecules must have the permanent dipole moment. If the molecule doesn't have the permanent dipole moment, it will not absorb the microwave region. Next, we have to see vibrational. So vibrational energy arises due to the flow motion of the molecules, that is stretching vibration, contracting vibration, and bending vibration of covalent bonds in a molecule. This IR spectra occur in the spectral range of between 500 to 4000 centimeter inverse. Since vibrational transition is accompanied by rotational transition, vibrational spectra is also termed as. So this is vibrational energy levels to and fro motion of the molecules. Examples: vibrational spectra are shown by the molecules like carbon dioxide, water, etc., so which has dipole moment of the molecule. Then finally we have to see this electronic spectra. So electronic energy arises due to the motion of electrons while considering the nuclei of atoms of a molecule as fixed points. So this electronic spectra occurs in the vibrational region of 12,500 to 25,000 centimeter inverse, those in the UV region of 25,000 to 70,000 centimeter inverse. So this is electronic energy of the electronic spectra. So we have seen electronic energy level, vibrational energy level, and a rotational energy level. So each and every molecule in the world will have some amount of vibrational energies. If it is in the normal condition also, it may have some vibrational energy. So this is universal truth. Thank you.